Check the audio level. It's all working. Good. Cool. Back here. Okay, new instructions on this one. New instructions on this one. This one says use limits to show whether or not the function has a horizontal asymptote on the left half of the plane. So you need either one flashcard or two. It just depends on your preference. So let me show you the choice you have. So right here, you can either make one card like the one at the top, or if that doesn't make good sense to you, you can make two cards to indicate left or right. So either way, either make the two cards at the bottom or make the card at the top. If you need help deciphering which one is more appropriate for you, just ask me and I'll help you. But it just kind of depends on how you see things. Like I like the one at the top. So if one card, good enough for me to understand that if I find a negative infinity limit, I'm finding a left horizontal asymptote. If I do a right infinity limit, I'm finding a positive infinity limit, I'm finding a right horizontal asymptote. Let's put those on the left and right. So either way, one card or two. I would put the blue on the front, I'd put the red on the back. So. All right, let's keep going. So back to number 20. So 20 is a left horizontal asymptote because we're instructed to look for one that's on the left, which means it's still the XY table, list of XY pairs. But now what we're doing is slightly different than what we have been doing. We're thinking of a table. Pull these out of the way a little bit. And our table would have something kind of like this. We're kind of working backwards. We're saying, oh, we want to know what happens to these XY pairs as X becomes increasingly negative. So something like this, where X becomes more and more negative. And there's no end to how negative X becomes. That's what we're being asked to find. Questions? Okay, so based on the flashcard, we're finding a limit. And you do need to get that burned into your memory. That has been a severe stumbling block for many years. So I'm hoping that this blue and red flashcard will help you all overcome what has been a severe problem in the past. People have struggled to remember that when a problem talks about an asymptote, a horizontal asymptote, they're talking about a limit. Like, and you should immediately make the connection. Like you see a horizontal asymptote, your brain says, oh, they're talking about a limit as X approaches an infinite value. So, please, Sophia.
This is kind of a silly question, but I just want to make sure the horizontal asymptote is when it's like the horizontal distance, so it goes like this, and the vertical asymptote is this because it's the, like, stops the vertical growth, right?
So you're backwards,
Okay,
but that's okay, no worries. And there's a couple of things that are also, they're misunderstood because prior to this class, whenever you've talked about a horizontal asymptote, you've only talked about kind of one kind. And in this class, they're going to test you on pretty much any kind. So let me just draw it out as a quick review. 3 points for Sophia for asking. So vertical asymptote on a graph, we've looked at that. that's where the limit on the left or the right goes infinite. Something like that. So that's vertical asymptote. Maybe that's what you said and I misheard, but are you good here? That's vertical. Okay? And you have a flashcard for that. It said if the left and right limits, one or both are infinite, you have a vertical asymptote. Comfortable? Cool. Horizontal asymptote is different. Horizontal asymptote is simply the answer to a limit as x approaches infinity. Like, there's no other part of the definition. This is it. Like, you go find that limit, and if it's a finite number, then you have identified the existence of a horizontal asymptote. A common misperception is that the graph doesn't cross the asymptote like that. That doesn't have to be true. I've seen a question before where they literally put a dot right there and do something like that. So the graph is a part of that dashed line, but on one side of it, again, the limit is going infinite. So they still call it a vertical asymptote. Are you comfortable with that? Okay. For horizontal, a common misunderstanding is that as x becomes, say, very negative, the y values will only get close to equaling some value. And they'll never equal that value. That's very common, but it's not required. You could have a function that actually did something like this. It actually was equal to the value a lot, and then it eventually kind of settled out. Even more unfamiliar to all of you, if I draw a horizontal line like that, that blue line is a function that has a horizontal asymptote. It's not very interesting, but by definition it has that. Carson, please.
Wouldn't that mean it has two? It can't go, it doesn't ever touch the positive or negative side of the line?
Oh, I gotcha. That's the problem. We all have in our mind that horizontal asymptote means you can't touch, and that's false.
It
For-
just,
Go ahead.
it has two on either side, that is what it meant.
No, it's just one, and that one horizontal, like, let's draw it out. Good question. So if I have a function like this, the function is f of x equals, see, what I'm trying to get you to delete from your thought is that horizontal asymptote is associated with not touching. That's false. Some functions have that behavior, and they have a horizontal asymptote, but that's not the definition of horizontal asymptote. There have been AP questions where they catch students on that. The student thinks that the function can't touch, and so then they mark the wrong one. The one Carson's talking about is like if f of x equals 3, like that, if I graph that function, 1, 2, 3, badly graphed, this function has a horizontal asymptote of y equal 3. And why? Because the definition simply is, as the limit approaches infinity or negative infinity, what's the value of the limit? The limit is 3. The function's always equal to 3. So that still is just one horizontal asymptote. I don't know if that answered your question, Carson.
Yeah.
Okay, please.
So just to clarify, we should think of an asymptote less of a wall and more of like an invisible line that describes the characteristics of a function?
You could. I think it's best for our class to just say, I'm not going to remember anything I learned previously. Honestly, it doesn't apply as much. I'm just going to remember limit. If you always go to limit, they won't trick you. Like if you just say horizontal asymptote, I go just test the limit. And that will answer the question as to whether there's a horizontal asymptote or not. That's really all it is. It's just the limit. That help a little. 3 points for Carson, 3 for Bridget, 3 for Sophia. Really encourage you to keep asking questions, as many as you want. Like, don't ever be like, if it doesn't feel like you're satisfied, ask again, especially with this horizontal asymptote thing. Because it has been a place where there's like 3 questions about horizontal asymptotes on the test, and those 3 are kind of some of the 3 most missed questions. But if you can get this limit idea fixed in your mind, then they're not really that hard. people miss them because they keep going back to their previous conception of what horizontal asymptote meant.
So you say for this function one, you just test it by plugging in the equation? But,
Close. Oh, keep talking, Josh.
How would you know if it's a horizontal asymptote for just like one of the graph questions, like on the buff page?
So on the buff, there actually were no, okay, let me back up there. If they give you a graph, it is kind of what Bridget was saying. You can look at how they draw the picture, and you can conclude that they are indicating the presence of a horizontal asymptote. Like if they draw something like this, okay, and then they draw some sort of function inside, like this, or maybe like this, that is showing you that that function has a right horizontal asymptote and a left. So the dashed lines are showing you that. And it is true that out here, the function's getting close to the value of the asymptote, but never actually equals it. Over here, same thing, but in between, the function actually does equal the value of the asymptote. So that's how they show it graphically. Please.
So for this specifically, what you're saying is that when it's getting closer to infinity, when it's going towards infinity, it's not going to touch the asymptote, but it can touch before that?
What Lily just said is 100% true. Say it one more time. You said it really well. No, you're fine.
Okay.
I'll help you to get stuff.
So as the function is approaching infinity, it's not going to touch the asymptote.
Asymptote, yeah.
Asymptote.
Terrible word, but you're good.
But it can touch before.
Correct. But the thing to remember is that's not a rule. That's just something that happens in some cases. So here's another one. They could draw this. No dotted lines. That function has a right horizontal asymptote and a left horizontal asymptote because the function is literally equal to, say, 2 over here, and it's literally equal to -7 over here. And it's equal to that forever. That's not what we typically think of a horizontal asymptote, but it fits the technical definition.
Okay.
So you have to watch out for that. Questions? Please.
So like if this is to be on a test, is the if like the function does pass or like cross the asymptote, then you kind of you don't really have to pay attention. You should ignore that part.
Ever hear what Massimo said? That has been one of the trick answers on previous AP tests, is they put some sort of statement talking about, oh, it's a horizontal asymptote, so the function can never equal that. False, it can. But a lot of people will check that box because they have that preconceived idea that it can't equal the asymptote. 2 more. Anybody else? Oh, please, Karen.
So on this, if it's a left horizontal asymptote, does it not have to go all the way to x equals 0?
Oh, it could. They're just asking us to investigate what happens as x becomes very negative.
Okay.
So what happens other places we don't particularly care in this case, but it could do whatever. So 2 more. Okay, so let's do this one together. So as I said to Bridget, the key is you focus on limits and don't focus on this idea of not touching. That's what some functions that have horizontal asymptotes, what I was saying to Lily, not touching is what some functions that have horizontal asymptotes do, but not all. So here we go. So we just focus on limit. So you should write on your paper, limit. Don't write equal yet because we haven't begun. So write the limit as x approaches negative infinity. There is no left or right. It's different. It's still a limit, but there's no left, right. X is just going to become more and more negative. Okay? There's no left or right. There's no overall. It's just x becoming more and more negative.
So we don't have to find the right side. We just have to find the left side on this one.
There really is no left side. Like in the previous limit, we had x approaching, say, 0. Well, it's pretty clear that if x is approaching 0, we're thinking about these kind of numbers that are slightly less or slightly more than 0. if x is approaching negative infinity, that just means x grows forever negatively. You're not approaching anything. You just keep growing. You hear the difference. 2 more. Okay, here we go. So we're trying to find the limit as x approaches negative infinity of that formula called f. So make sure you write f. And we'll put an equal because we're going to proceed straight down the page. The page is laid out in a column because I have learned for 18 years that if you go sideways, you make twice as many errors as you go down. Down is much safer. So that's why I'm kind of directing you to go down the page. Right, we're finding a limit. Step 1 does apply. Step 1 does apply. So I need you to refocus now. Just make sure you're really with me. Compare terms that add. That means we've got to find some terms. Terms, by definition, are items that are adding, but students kind of struggle to remember that, so I still leave it as terms that add, just as a kind of a double emphasis. So you need to look at f, the formula. You need to raise your hand if you can tell me if you see any terms that are adding. Raise your hand. Who can see terms that are adding? Term just means things. Like I have this sign here by a student, Amanda Lindstrom. She really struggled with this, so she left me a sign. She's like, oh, once she got this down, it really made a huge difference for her. Terms are when you got a thing plus a thing plus a thing. How she said it. So who can see things that are adding? So let's go, hands up. If your hands up, give yourself 2. We'll go to Ella. Name 2 things that are adding, Ella.
The negative 2 and the negative 1.
Negative 2. Oh,
I mean, like, I don't know if that's what you meant.
You're
but-
great. Don't even worry. I can see exactly why you said that.
Yeah.
Totally valid. Just stay with me for a minute. What I was looking for was slightly different, but not much. Not much. I want to see something that's added to something.
Okay.
So you tell me something that's added to something.
No, I'm just confused.
Oh, no worries. So 3 points. Let's go, Carson.
Wouldn't you factor the 4x squared minus 1, and then, what is it? You've got the 1 positive, 1 negative.
You could factor that. If you factor it, will the factor that you create match either factor of the numerator?
No.
No. So 2 more points. So not wrong, but not helpful. Like if I can't divide it, factoring is not really going to help. Clara, tell me 2 terms that are adding.
The 3x and the negative 2.
There we go. 3x is a term. There's a hidden plus sign, and you're adding that to this negative 2. Those are 2 terms that are adding. That's what we mean by comparing terms that add. 3 points for Clara. Anyone want me to talk more about that? Somebody tell me 2 other terms that are adding. Go, Lilith.
So then the 5 is adding to the negative 6x.
Perfect. So we got 5. There's a hidden plus sign again. And it's being added to the 6x that's negative. Questions? Well, Carter, what's another 2 terms?
4x to the power of 2 minus 1.
So we have 4x being added to the negative 1. I'm about out of colors here, but I think I was able to keep them all separate. 3 points for Carter. And these are factors. We can't lose these parentheses. Those are critical. Questions from anyone? Okay, here's what it means to compare terms that add. You mentally think about the idea that you're going to plug in these values in place of the x's. And you're trying to deduce what's going to happen. So as an example, we were to plug, say, negative 1 into this factor here, we'd get, so I'm just doing some scratch work here. This isn't part of your main work, just some scratch work. So we got 3 times negative 1, and that gets added to a negative 2. Let's see, that would equal negative 5. But then I take 3 times negative 1,000, and I add that to negative 2, and I end up with negative 3,002. And if I did it with the million, get something like this, plus a negative 2. That's going to equal negative 3 million and 2. Does anyone have any question about the pattern that we're observing? Okay, here's what you ask yourself now. You have 3x here, you have negative 2 here, you're adding them. As x becomes increasingly negative, do these two terms continue to contribute kind of equally to the total, or does one of the two start to become completely dominant, like overwhelming the other? Hands up if you know. Hands up if you know. Do they continue to, like we've got these two terms, we've got the blue one, and we got the yellow one. The question is, they're going to add, just like you see here, for different values of x, but x is going to get more and more negative. As that happens, do those two terms have equal importance as far as their total, or does one become much more important than the other? Hands up. Got about half the class that's ready to answer. The other half is still not sure. We'll try, let's go Annie.
I think that the first term becomes a lot more important because you're multiplying it by an increasingly bigger negative number.
Perfectly said. The 3x becomes, as x becomes more and more negative, 3x becomes more and more dominant. So the more negative you make x, the more dominant 3x will be in terms of that sum, that those things added. Point if your hand was raised, 2 points for Annie. So that logic allows me to write this. This limit of f is equivalent to a much simpler limit. I can reduce what I have to think about. I don't really need to think about the negative 2. Adding the negative 2 to 3x, as x becomes increasingly negative, will become increasingly less important. And in an infinite sense, it will have no importance, because x is going to grow infinitely negative. We want to talk about that.
How come you didn't write that for x on the
Oh, what I'm doing, 2 points for Lily, is I'm replacing the symbol f of x with the actual formula. But I'm doing a simplified version of the formula to make the math easier. I'm using this idea of comparing terms that add, and I'm saying, oh, really, I don't need to worry about the 2.
Okay.
So I'll just not write it.
So 3x is going in place of the f of x.
Close. It's going in place of a portion. We got more to go.
Okay.
So other two terms that we're adding were the 5 and the negative 6x. So hands up, whole room. As those two add together, right here, 5 and negative 6x, is one going to be dominant? Hands up. There we go. Let's go 2 points if your hand is raised. And Chase, what do you say?
The negative 6x.
Crucial that we keep the negative. That's an important part because you're comparing things that add. So this would be negative 6x. So back to Lily. I'm not writing exactly what f is. I'm writing like an abbreviated version. But because of this argument right here, how as x becomes more negative, only one of the terms is really important, I'm finding a limit of something else that's not really f. But it will have the same limit as f.
Okay.
That's why there's an equal sign here. Does that feel okay?
Yes.
Good. Anybody else? Solid. So now you just look at the bottom. Hands up. Who knows what to do with this thing here? What do we do with that? Those two things are adding as well. You're comparing terms that add. As x becomes more and more negative and those two add together, will they continue to have kind of equal importance, or will one dominate? Hands up. Let's go, Parson.
I think they're both going to have importance.
So 2 points. I got to convince you now that that is incorrect. If you plug in like negative 1,000,000 squared, I don't know what you get, but it's really big. You multiply that by 4, that's bigger, and then you're adding it to negative 1. The negative 1 is not contributing much.
Oh, I thought you were talking about the 3x.
Oh, no worries.
6.
Are you good at that?
It's 4.
Yeah, you're good. So the bottom here would be 4x squared. 2 points for Carson. Questions from anyone? Okay, keep referring to Lily's comment. It's super valid. We were asked to find the value of the limit of f. We're no longer finding the limit of f. This is not f. That's some other function. But the limits are equal. And it's easier to find the limit of this function than it was of that one. That's why we did it. Yeah, please.
So like what you said just a minute ago, where we're comparing the importance of them, if it was like 3x minus 2x, would that change things?
Awesome. 3 points for Christian Hansen. If you had a 3, it's a good way they could try and trick you. If you had this, they're kind of subtly wondering if you'll notice that that's really the same thing as just this. And so then you would want to just use this. Because you're right, as x gets more and more negative, these kind of retain their importance. Please.
If it was like a 3x squared minus a 2x, would the 3x squared just have more importance because the squared makes it something bigger, and then that's how you do that?
So I couldn't hear exactly what you said, but I'll write something that's at least similar. Is that kind of what you said?
Yeah.
Okay. Turns out that if we play with the computer a bit and kind of play with the numbers, the power is what's important. So the squared term, as x becomes either more and more negative or more positive, will completely overwhelm the unsquared term. Did that answer your question? 2 more. Now here's a chart to kind of maybe help that sink in. If you want to take a picture of this, you're welcome to. This is just made with a spreadsheet. Look, here's like x becoming more and more negative. This is exactly what Sophia just talked about. This is -5 times x. So yeah, it gets bigger and bigger as x becomes more and more negative. This is, the 3 doesn't really matter, it's the fact that it's n cubed. Notice here, when x is -1 billion, which compared to an x that grows forever is not very much, look how much bigger the cubed term is than the non-cubed term. That's why we declare the cubed term to be the dominant term, and we can ignore the non-cubed term. Like if you compare over here, the spreadsheet had no ability to even include this. There's no 5 here. Like it's being told to use it, it can't. The computer literally can't deal with the difference in this size versus that size. So it does the best it can and just writes down that. So, questions? So if you're making lots of money, be careful because the computer will make an error, then you'll lose your $5 billion. I'm in the rounding. Question? It's true. Okay, back to your 20. Okay, we're almost done now. We have a much simpler limit to determine. And what I would do next is simply rewrite the limit one more time to make it just a little easier to think about. So I'd say this limit is equal to this one now. Okay, this yellow box is composed of only factors. That's really good news. Once I have only factors, I am free to rearrange the factors any way I choose. So I rearrange them in a convenient fashion. -18 over 4, and this would become x squared over x squared. This green box is exactly the same as the yellow. I've just rearranged things to make it more convenient for me. Please.
Are those two like separate fractions, or do we multiply by each other, or are they just
Thank you.
separate?
The dot is optional. Without the dot, it still means multiply. Good question. 2 more. Yeah, please. Vivian.
Would x to the second power of over x to the second power just turn into 1?
Perfect. Answer this, Vivian. As x becomes increasingly negative, like this, it doesn't really matter what x you're picking. You're always ending up with some value squared divided by same value squared. So that is absolutely 1. So this is telling you that as x becomes increasingly negative, this whole thing is just getting close to whatever the heck 18 over 4 is equal to. Which means the limit of this thing is 18 over 4, which means f of x has a horizontal asymptote. It's on the left-hand side, so I often refer to it as a left horizontal asymptote.
Could we do like LHA?
For the homework, feel free. For the test, they want you to write it out. And they don't actually use the word left. That's just me. I think it's easier for us to talk about it.
Okay.
Yeah, they'll just say horizontal asymptote at a y value of -18 force. If you want to reduce it, you can. It's not required. So I vote to just quit. Don't reduce. So. There's really wisdom in that. Like in my 15 years in industry, you're always trying to find the right balance between doing the work yourself and kind of going and bothering is the wrong word, asking your boss for help at kind of the key moments to kind of keep the project moving forward at the right pace. Vivian?
Is it legal, mutation to put an ampersand there, or should you write out the?
Oh, ampersand's fine. They're fine with that one. 2 points though, please, Josh.
How would you know if there wasn't a horizontal asymptote? Would
Oh.
you know that if they're both positive, or?
What would happen if there's not a horizontal asymptote? This limit will become either positively infinite or negatively infinite. That's it. 2 more.
So the answer is just that place has a horizontal asymptote at y equals
That's the answer. Please. 2 more.
Should you, like on the test, would you need to simplify -18/4?
No, they accept that as a perfectly valid answer. So I defer to the just quit.
Okay.
Smarter. 2 points. You have to ask your sister. A memory occurred to me. I swear, like a couple of years ago, we were coming back from some trip. I think it was Hawaii or something. We're at the Salt Lake Airport. There's gigantic escalators now in the new airport. We're like, my wife and I were coming down on this side. I swear Eliza was going up on this side. And she's like, she yells out, Mr. Smith. I'm like, who said that? I go, oh, it's Eliza. Like, hey, see if I'm remembering if it was her. Maybe it was somebody else, but I think it was her. Anyway, double check for me. Okay. Questions here? Solid, that's it. Let's stop the video then and do another one. Get you well prepared for the homework.